Welcome. Hi, everybody. Welcome to Geophysics Champions. Today, we are joined by Ron Bell. He is president and consulting geophysicist of Robotic Geophysical System. He began researching of drones for photogrammetry, remote sensing, data acquisition, geological and topographic mapping, and others. We are so happy to learn about you and appreciate it a lot your experience. How are you, Ron? Tell us a
I'm
little
fine.
about yourself.
Well, thank you. Thank you. In terms of my background, I've been in geophysics for since the mid 70s. And I've been doing a lot of mineral exploration, oil and gas exploration, environmental work, some engineering work. Some of it's been airborne geophysics, most of it's been ground geophysics. And that background led me to looking at drones about 7 years ago. And I'm kind of anticipating that you might be asking how I got into drones. And what really got me into drones was to look at it was I was out in Nevada conducting a ground geophysical program. And it had dawned on me that we were doing it pretty much the same way we've always done it. And I decided when I got back to Denver, I'm based in Denver, that I would begin looking into other approaches to collecting geophysical data. Let me say that was the fall of 2013. I happened to have a friend who I was talking to him about, I'd heard about drones, but didn't know a lot about them. And I was talking to him about them, and he told me about a meeting that was happening in January about a group of people who were in the GIS business primarily, that were going to have a presentation from a gentleman at the USGS, as well as a gentleman from the Bureau of Land Management on how they're using drones. And so I went over and attended that presentation. And during the process, it became very evident to me that the drones were really going to change the way that we think of doing geoscience.
Yeah, that's true. I'm totally agree with that.
But what really got my attention, because I come from a geoscience background and experience, was they were mapping fractures. They were taking photos from above and actually able to map fractures in this formation. And I don't think that was the intent of what they were doing, but it really struck home to me that was a real valuable thing to be able to do. After attending that meeting, I introduced myself to the gentleman and I visited with him a little bit. I began looking into drones for doing geophysical measurements as well as doing photogrammetry and LiDAR. LiDAR hadn't quite gotten to the point of being common at that point. It was another couple of years before everybody thinks of LiDAR now as in a number of senses, but actually still very viable technology and still experiencing some growth. I tended to, because of my geophysical background, I tended to think of in terms of the geophysical measurements that I could make with a drone.
Related with this, what are you doing with drones today? What is the most important contribution of them in the development in the near surface geophysics?
Well, magnetometry was the first real sensor to be utilized on drones. There's a number of people right now that are flying drones commercially using doing magnetic field measurements. A lot of that was done for mineral exploration, and a lot of it's done in Canada. I looked at it, and about that time, I had a connection to geometrics. This would have been 2016. And in 2017, they gave me the opportunity to test out a prototype of a drone magnetometer that they had conceived and designed. And that led, in 2017, I flew the first drone magnetic survey with that prototype. It was more of a test survey. We flew several surveys here in Colorado at various different environments. Some of them were for mapping geology for resource exploration. Others were for locating things like abandoned oil and gas wells. and pipelines, which have a unique magnetic signature. 2018, we continued that research, and in the fall of 2018, Geometrics brought out the first production version of their magnetometer. It's called the Mag Arrow. If you're working on a budget, and drones are really about working on a budget, at least they are today, you don't really want to have to add on more. There's two things you're working on. One is the cost and the weight. These small drones only have a limited capability in terms of lifting its payload. So you don't want to add more weight. One way to, if you can avoid it, and one way to do that, to get away from that, is to actually suspend your aircraft, your sensor, some distance away from the aircraft, so it no longer is being, it's not measuring the field that's created by the drone.
I had a question. What is a geodronologist? I think that, can you spell this word for us?
Yeah, it's a GEO, drone, and I put it in caps to emphasize that it's using a drone. It's capital letters, DRONE, and an ologist. Basically, you take a geologist, is split
the
it
science.
Apart. The scientist, and you put drone in the middle. And I realized that I was using, my primary purpose for using drones was to map geology. And whether I'm using it to map photogrammetry, the surface of the earth, or LiDAR to map the rugosity or the texture of the earth, which helps in understanding the fracture systems, and that's a helpful thing. Or whether I was using a magnetometer, my entire goal was really about mapping geology. So I coined the term geodronologist, and I didn't immediately call myself that, but that's what I now call myself. I graduated from being just a geophysicist to being a geodronologist.
It's very creative. Congratulations.
well, thank you. Well, thank you. When people ask me what I do, I felt it was a little bit lacking to tell them I was a geophysicist that used drones. I felt that it was more expressive to tell them or inform them that I was a geologist. I was mapping geology with drones. And I think that pretty much captures why I use drones.
What are the basic concepts that young people must learn to be introduced to the use of drones, related to sensors and software to understand the processing?
I do a lot of thinking about, let me share this with you. I do a lot of thinking about why drones are appealing. Okay. And early on, they were appealing because they allowed me to go to places and capture data, capture an image from above, like a bird's eye view thing. You can see a lot more when you're above the earth than you can see when you're just standing at it, looking out in any direction. But when you're above it, you can see how things lay out. In some cases, that can help you actually map the geology. You can see things that you wouldn't been able to see on the ground. Now, I've said, I've shared that, yeah, you need to know something about color photography. You need to know something about photogrammetry, how to put all of that information together and extract information. Usually it's a map of an ortho-rectified photomosaic. You can get a digital elevation model. You can extract that from orthophotomosaic. And then if you add in LiDAR data, which is what a lot of people do today, you can actually say something different. You can work in areas where there's a lot more vegetation and cover that you can actually see below it. So now we're starting to understanding something about each of those sensors starts to make sense for somebody who wants to get into drones and how they want to apply it, what they want to apply it to. And back to your sort of question is, what should young people consider? Well, it's exciting. I think this is a really exciting time for entering the profession of the geosciences, whether you're a geophysicist or a geologist or whatever part of it you want to be in, the drones will have an impact on your work, and they're exciting to get involved with.
Now that you mention it, I think that the environment contribution of all the application of drones is very, very important now because
Yeah, I,
it's helpful.
I envision that we're going to see drones being able to help better quantify the processes, the Earth processes, map them. And another real good attribute about using drone-based mapping is you could put the drone up again and do it again. You can map it once, and then you can wait a period of time and do it again. So you could look, you're really going to be seeing changes. Just subtract the two or apply processes to the two, and you're seeing change. That change can be very helpful in understanding the dynamic processes of what goes on in it, as well as what human beings are doing to the earth.
If we're changing a little the topic, what do you think about the profitability of geophysical work with drones in your surface geophysics exploration?
Yeah, profitability. Well, obviously, I'm in the business of providing geophysical services. I'm testing various types of sensors. I started off with magnetics. I'm currently working with an electromagnetic sensor system that looks at the near surface. I expect to be in the early part of the year to be testing a gamma ray spectrometer on a drone and testing the viability of that. I have another electromagnetic sensor that I'm hopefully will be testing in about a month and a half. And what I see is that we're going to just see a whole bunch more geophysical sensors, and that'll allow us to understand what's happening in the subsurface or map it. There are those that are using ground penetrating radar. We have some issues in the US with using radars on a drone, but they will be available to us. And some are looking at making magnetic field measurements on a drone. I don't know how effective that will be, but 5 years ago, I didn't really understand what the impact of drones would have on any geophysical measurement. So I think that what I'm saying is there's a whole lot of innovation coming on in terms of developing new sensors, new thinking about sensors, and making them smaller, making them lighter, making them not require as much power, and so that we can fit them on these small airborne robots.
The last one question, I think that is very important. So, what do you see as the future of drones?
Well, 2021, we're going to see in the future, in the coming year, they're currently talking about preparing for another summit on drone geophysics, which will be an online event in the fall of 2021, probably in the early part of November. The use of drones is expanding, actively expanding into the unexploded ordnance area, mapping bombs, and whether it's a magnetometer or an EM system or a GPR or whatever, we're going to see more of that. We're going to see gamma ray spectrometers to map not only geology or alterations in geology. Well, we'll start to see them being used as ways as security devices. That is, and so we'll see what we would traditionally use for mapping geology. We'll see being used in other sectors. We're going to see more in engagement in photogrammetry, LiDAR, and remote sensors in the infrared domain, being combined with subsurface geophysical data. We'll see a lot more of that in 2021. The major markets will always be resource exploration, oil and gas and geothermal and groundwater. Those will be the major drivers. But we'll also see a bunch of environmental work being now addressed by drones. And it's just not, will at the end of the 2021, we're going to be seeing pressure to actually build larger drones and in the next couple of years.
Thank you for all the information, for share your experience, for your participation on this interview. It was very productive for us to know the advantage of this instrument.
Thank you again for the opportunity to share, and have a great day.
You too. You're welcome. And thanks to you for your participation. Have a good day too. And see you soon.
See you soon. All right.